Hello, I'm Ravi Rangan, training students for IIT JE and AEEE in Visakhapatnam, a beautiful city in the state of Andhra Pradesh in India. I'm also authoring some of the write-ups for physics topics in a magazine, in a All India magazine, IIT Buzzword. And presently, I'm also in the work of writing some of the topics in mechanics. At the outset, I would like to just give a small introduction about the beauty of the subject before I could give a series of lectures on different topics like mechanics and electrostatics, electricity, and several other topics in physics. As most of the students know, some of the natural phenomena, what we see around, can be explained on the basis of principles of physics. See, we have so many natural phenomena happening around us. For example, if you see the sky, if you see out through the window, the sky is blue, and you see the happening of the occurrence of the solar eclipse, and also you see the morning sun is red in color, and also during sunset, also it is red in color, and so many other natural phenomena also we do have. But what are the reasons behind these things? Can be explained only on the principles of physics. For example, if you take the sky appearing blue in color, it's mainly due to scattering of light. If you see the sun's white light, it contains 7 colors, and in that we know the blue has lesser wavelength, therefore more scattering. That's the general principle of physics. And this blue light is carried by the atmosphere, by the particles in the atmosphere. Lesser the wavelength, more the scattering. So blue has lesser wavelength, and thereby the blue light gets scattered into the atmosphere, and it appears to be blue in color. The sky appears to be blue in color. So that is the reason why it is so. Is the sky not blue hundreds of years before, thousands of years before? Definitely yes. It was blue and it is blue in the daytime. Previously, long years back, so many years back, we don't know the reasons. Today we know the reasons, which can be explained on the basis of principles of physics. Similarly, another example let us take solar eclipse. We know the solar eclipse occurs only when the sun, moon, and earth come along a line. The shadow of the moon falls on the earth, and that part of the earth experiences night sky, like, or in other words, it appears to be dark. They experience the night there for some time. But the reason behind here is nothing but the shadow of the moon falling on the earth. But long years before, we do not know the reason. But today we know the scientific reasons behind that. That means what I'm trying to explain is we only discover in physics. We don't invent anything. No one can say, I invented something in physics. Like that, several other examples. For example, if you take the morning, in the morning sky, the sun appears to be red in color. Similarly, during sunset, it appears red in color. What are the reasons behind? In the early hours, in the morning, when the sun rays come through the atmosphere, we see that all the color gets scattered, many of the color gets scattered, but the red has greater wavelength and less scattered. Thereby, it will manage to penetrate through the atmosphere layers and reach the point where we are, and thereby the sun appears red in color. That's nothing but greater the wavelength, lesser the scattering. The same phenomena happens during sunset also. That means now we know the reason why the early morning sun and the sunset, during the sunset the sun appears red in color. So like that, uh, some more examples, natural phenomena you can see. Suppose you are sitting inside a room, and if someone asks you a question, if you go several kilometers up where there is no atmosphere, what is the color of the sky? Definitely, if you are knowing the principles of physics, definitely you will try to assume and try to give an answer for that. And you will think and give a reply. Definitely, there is no atmosphere, no particles. Therefore, the no color, blue color is not scattered. Or in other words, the sunlight is not scattered at all. Therefore, the sky appears to be dark, like the night sky. In other words, if you go to several kilometers up above the atmosphere layer where it's almost vacuum, there from there if you see the sky, definitely it appears to be dark because no particles to scatter the sunlight. That means sitting inside the room, you will be able to predict what would be the color of the sky above the atmospheric layer if you know the principles of physics, even though you have not experienced it really. Isn't it not so beautiful? Very good, isn't it? Yeah, definitely. That is the reason why I say physics is a very beautiful subject, because we are able to predict the answers which we don't experience, and definitely when you experience and if it matches with your answers, really it remains very enjoyable throughout your life. So like that we can explain so many natural phenomena happening around us, occurring around us by the principles of physics. Before I could go into the series of lectures, I would like to tell you that for solving the numericals in physics, we require mathematical tool, that is a calculus, derivative, that's called differentiation, integration. All these topics are very much required to solve the problems in physics, especially for IIT JEE and AIEEE also, and other state level examinations also. So one should try to learn the calculus part and grip differentiation and integration thoroughly, and try to understand what is differentiation and integration in the real sense, but not just by solving the integral formula or derivative of certain function, integral of certain function. What do you mean by derivative of a function? You should understand. Many students can solve it but do not know what actually derivative of sine x is cos x, they say. What is the meaning of that? Actually, when we say derivative, it means we are finding the slope of the curve for that function. In other words, derivative is nothing but slope finding. Integration is nothing but area finding under the curve for a given function. And you may ask me, why do we learn slope finding and area finding? In physics, finding slope of certain function gives you certain physical quantities. Similarly, finding area under the curve, that's integration, also gives you certain physical quantities. That is the reason why we study the derivatives and integration in mathematics, and it's extremely useful in solving the physics problems. So I would like to give you a lot of emphasis on this aspect. Every student should know the derivatives and integration by actually understanding what it means and how it can be applied in the problems of physics. So students should definitely keep in mind derivatives and integration are extremely important for higher level problems in physics. Um, if you take many examples, for example, if you take light, what is light? Light is an electromagnetic radiation, all of us know. X-rays, gamma rays, infrared rays, all these are electromagnetic radiation, no doubt. In this large electromagnetic spectrum, we have a small width that is nearly 4000 to 8000 angstrom units, which we call it as visible region. What is this visible region? That means when these wavelengths, that is 4000 to 8000 angstrom units approximately, which when incident on an object and get reflected, and if that reflected light enters the eye, that object is visible. That's how objects are visible. Thank God we have this spectrum 4000 to 8000, and our eye is sensitive to this and make the objects visible. We have to thank God for that, because in the large electromagnetic spectrum, God has given a small bandwidth which makes objects visible. Light is not visible. Light makes objects visible. I think you followed this very important point. Okay, light is not visible. Light makes objects visible. That means this is a small aspect which everyone should know. Those who study physics, they can know the small phenomena around us. What is light? What are X-rays? What are gamma rays? When you try to know these things, you'll enjoy the natural phenomena happening around us. So the beauty of physics is you can sit inside the room and predict certain phenomena, natural phenomena, which are likely to occur based on the principles of physics. And when it happens so, and when you experience whatever you have predicted, really it's awesome. The enjoyment what you have has no boundaries. That's why I call it as a wonderful, beautiful subject, which you cannot imagine how beautiful it is. In fact, our complete lifespan will not be sufficient to relish the subject. In other words, as we keep on reading the concepts and solving the problems, we find that we are tight packed in our schedule, and we feel as if we don't have sufficient time to assimilate the complete subject. So as you go on learning, you find so many new things which we are yet to learn. So that is the beauty of the subject. We can predict certain uh, answers by the principles of physics, and when it naturally happens so, that is really we find no boundaries for our happiness. So I am planning to give a series of lectures on mechanics especially, and also on electricity. In mechanics, I want to cover like topics like kinematics, friction, motion of bodies on inclined planes with friction, without friction, and circular motion, and electrostatics, current, electricity, and some more topics. I am planning to give a series of lectures. Actually, this is a small attempt of mine to explain some topics in physics, so that the student community not only for the aspirants of IIT JEE and AEEE, for the complete student community across the globe. I hope these lectures which I am planning to deliver will be definitely much useful, because I am trying to give shortcut methods for many problems, because there are several problems in mechanics which can be solved by force equations, Newton's laws of motion, and the same problems can be solved by conservation of energy also, or work energy theorem. I find that wherever possibility is there, a student should apply conservation of energy and work energy theorem to make the problem less cumbersome and get the answers quickly. So what I would like to say is my topics which I am planning will give you more emphasis on shortcut methods to approach a problem and solve it properly by using mostly conservation of energy and work energy theorem. And some of the problems will be covered where the methods involved are my own ideas, which gives you a very, very shortcut method to solve the problem. So I hope and trust that the lectures what I am planning will definitely be useful to the student community in particular, and all the people who are physics lovers who are trying to know the actual sense of physics in general. Thank you.